All About Water is a project-based curriculum for K through 2 classrooms to learn more about Earth's water, soil, and climate. This curriculum is modular, divided into 60-minute blocks, and may be done as a whole or as individual lessons. Activities can also be adapted for virtual and remote learning. More details are provided later in this video. Each of the 3 All About Water lessons are aligned to the Next Generation Science Standards, or NGSS. The complete list of these standards can be found in the curriculum. This video provides an overview of Lesson 3, Drought. This third lesson spans 2 60-minute blocks in which students explore what plants need to survive. The lesson ends with an opportunity for students to learn behaviors to help conserve water. For Activity 1 and 2, students work in partners or groups of 3. The most effective learning outcomes happen when students have authority to drive experiments and discover key phenomena on their own, creating and sharing explanations with their peers. As an educator, you have a special role to help facilitate this learning process and guide students' understanding by asking leading questions. It is okay if you are unfamiliar with the phenomena, and in fact, this is a great opportunity to model curiosity. In the first block of Lesson 3, students explore dry, damp, and wet soil. Then, students use their observations to design a set of experiments that explore how various types of soil support water retention and plant growth. For Activity 1, students explore how properties of soil change when dry, damp, or saturated. This activity works best with a variety of natural soil samples, as natural soil contains different materials and behaves differently than potting soil. You may use the same soil as in Lesson 2, filtering water through the earth. If you do need to purchase soil, purchase sand, topsoil, and potting soil. This activity is best done with completely dry soil. To get dry soil, leave all soil samples in direct sunlight for 5 to 7 days. Alternatively, bake the soil in the oven. Bake the soil on low heat, around 200 degrees Fahrenheit, for about 2 to 3 hours. This will evaporate the water from the soil. Once dry, be sure to let the soil cool fully before pouring it into bags. This activity is also likely to be messy. It is recommended to supply students with hand towels or napkins and use bins or newspaper underneath students' workstations. Here is a collection of materials you will need for this first set of experiments. To facilitate this activity, start by giving some information about what students will be doing and ask them to share what they have observed about how and when soil changes over time. Some examples of leading questions might be, after it rains, do all soils stay wet for the same amount of time? What do you notice about soil in the winter? What about in the summer? For this activity, students investigate as a class 3 different types of soil in rounds, taking time to write down their observations before moving on to the next sample. If available, students should use a magnifying glass to get a closer look. To start, pass out napkins and plates with the first soil sample that is completely dry. Students observe and feel the soil with their hands, recording their observations on their activity sheets. Then, fold the paper plate in half, have one student pour the soil sample into a bag. Students add water using eyedroppers so that the soil becomes damp but not completely wet. Student observe and record their observations. Students repeat adding water to the soil sample until the soil is saturated or there is standing water. Students observe and feel the saturated soil, again recording observations in their activity sheets. Repeat this process for the other 2 soil samples. After cleanup, facilitate a discussion about water's effect on various soil types. Examples of questions might be, what did you notice about soil number 1? Which soil made your hands the dirtiest? Why do you think that might be? What soil do you think absorbed water the most? How do you know? Additional sample scripts and suggested questions are provided in the curriculum. For Activity 2, students test how well soil types support water retention and, subsequently, plant growth. Using the same soil samples as in Activity 1, students water seeds with different amounts of water to test the effect of under and overwatering. This activity requires a 1 to 2 week waiting period for sprouts to grow. During this time, students periodically observe the plants and record their observations, comparing their findings across class groups. To jumpstart seed growth, place seeds in a food-grade plastic container 1 to 2 days before the activity and pour hot distilled water over them. Allow the seeds to soak for 24 hours. This activity also requires access to a window or wall that receives sunlight. Prior to the activity, have students observe and draw plants in their homes and outdoor environments on blank paper. What do students notice about happy and healthy plants? What do they notice about sad and unhealthy plants? These are the basic supplies we'll need for this activity. Begin by having student groups choose their favorite soil sample for the experiment. For each group, pass out 3 bags for students to label with the numbers 1 for no water or underwatering, 2 for some water, and 3 for plenty of water or overwatering. Students add equal amounts of soil and seeds to each bag, tossing the bag lightly to make sure the seeds are covered with soil. Decide as a class how much water to add to bags 2 and 3, and have students record this on their activity sheets. Students measure out the water and then add it to their bags. Call up student groups one by one to tape their bags to the window, noting which soil sample each group is using. It may be useful to write this on the window with a whiteboard marker. As seeds begin to sprout over the next few days, have students draw their observations on their activity sheets. Students may use their magnifying glasses to get a closer look. After 2 weeks, students observe all 3 bags and record their observations. If possible, continue allowing seeds to grow and encourage students to observe the plants and use their observations to determine when the plants need water. Facilitate a class discussion on what students observed about the seeds when planted in different soils and watered with different amounts of water. Sample scripts and suggested questions are provided in the curriculum. In this activity, students build off of their work in Activity 2 to explore steps they can take to reduce water usage during a drought by creating posters to take home to their families. This activity is best done independently, with students sharing their posters with the rest of the class. Here are the materials we'll need for this activity. Using resources from the Metropolitan Water District of Southern California, facilitate a discussion about how humans might help each other and the plants and animals in their environments during a drought. Sample scripts and suggested questions are provided in the curriculum. Have students draw posters of their favorite water-conserving habits. It might be helpful to quarter the sheet and have students draw multiple steps in quadrants like a comic. Some students may want to draw their creature from the Creature Connection pre-lesson. As students finish their posters, encourage sharing amongst the class. Then, help students gather together their All About Water experimental results in a stapled packet and send home to share what they've learned with their families. This curriculum is adaptable for virtual learning. For specific suggestions, watch Lesson 1 of the Water Cycle and read through the virtual considerations section in the curriculum. Suggestions for further exploration of key concepts can be found in the Extensions section of the curriculum. And with that, we have covered Lesson 3 of the All About Water curriculum, Drought. More details about the science behind each of these activities can be found in the Science Overview section of the curriculum. Go forth and empower your students to ask questions, conduct experiments, and explore the wonderful world around us. Thanks for watching!